Good morning, everyone. Today we are going to start the chapter number 8, Architectural Modeling. So these are the contents from the chapter number 8, Architectural Modeling. We will see the we will see about component diagrams, then collaboration diagram, deployment diagram. We are going to cover component diagram, deployment diagram, and collaboration diagram. So here first we will see about the introductory part regarding the architectural modeling. So here basically there are two types of UML diagrams for showing the implementation phase of the system, and this also shows the physical and logical structure of the system. Physical and logical structure of the system. So here physical structure and logical structure. And there are two implementation diagrams here, that is deployment diagram and component diagram. Here that physical structure gives, like it gives the details of hardware and software decompositions, then physical locations of classes and objects, that is in which the programs and the classes are actually defined in the system, that is physical location of classes and objects. Then it gives the dependency among the programs and the connecting hardware device, that is physical structure. And logical structure gives the function of the system and relationship association among the classes and objects. Then it also gives the collaboration among classes to implement the functions. So here that UML diagram shows the implementation phase of the system and also shows the physical and logical structure of the system. Then there are two implementation diagrams are there for this. First one is component diagram and second one is deployment diagram. So here architectural modeling. Architectural modeling means it is an architecture, or an architecture is the set of significant decisions about the organization of a software system. So basically, architecture is a set of significant decisions regarding that software system. It also guides about the elements, their interfaces, their collaborations, and their compositions. So here, architecture can be defined at both logical and physical level. We have seen that logical structure and physical structure. Here, so logical architecture shows the more generic view of the architecture, and the physical architecture describes more details that how software and the systems are designed. So this is about architectural modeling. Here you can see that architectural modeling. For now, we have seen that there are two implementation diagrams are there: component diagram and deployment diagram. So first we will see about the component diagram, or what is the component. So here component is a subsystem, or it is a subsystem of the complex target system. It is a distributable unit of a software. Component is a distributable unit of a software, or a component is a subtype of a class that has properties and methods, or as any other class, like any other class component having properties and methods. So here every component like any other class takes parts in associations and generalizations. So your component describes the physical aspect of the system. That physical aspect of the system is the component. You can consider the examples for that component like executable files like .exe files, library files, which are reside in the nodes. Whenever we are going to deploy that we are going to end up with the implementation of particular software, and at the last we are going to hand over that software system to the end user, like we are going to give the application in the format of executable files, so that exe files or that library files are reside in the that we are consider this as a node. Then here component diagrams. So here component diagrams are one of the two kind of diagrams found in the modeling the physical aspect of that object oriented system. So it shows the organizations and dependencies among the components. It shows organization and dependency among the set of components. So it also describes the organization of the physical software components, including source code, runtime code, and executables. That component diagram contains the physical software components like source code, runtime code, and executable files. So it is high level reusable parts of a system are represented in a component diagram. In component diagram, we are going to represent the reusable part of a system. Visualize the static aspect of a physical components and their relationship to specify their details of construction. So that we are collecting that various executables, library files, tables, that is physical things here we build in the component. Then the elements of a component diagram. So component of that elements of that component diagrams are like components, interfaces, ports, connectors. So there are several notations for the component. So component can be represented like, here you can see the elements of a component diagram. See, first one is components. So we have seen about components. Components are made up of one or more classes and describes parts of an application that can be assembled and reused. So it is a combination of classes, one or more classes that describes a part of an application. So like we have seen that component can be exe file, library files. So it defined as a physical replaceable part that conforms to and provide the realization of a set of interfaces. So here you can see the notation for component. Graphically, a component is rendered as a rectangle with tabs. Here you can see the component with rectangle with tabs with the name of the object in it. Here, name of the object in it preceded by a colon and underline. Here you can see admission.dll file. This is the library file. Example of component. Component can be represented as rectangle with tabs. Then another notation for the component diagram is the interface. That interface is a collection of operations, that are used to specify a service of class or components. We have seen about interfaces. Interface is a collection of operations that are used to specify a service of a class or components. So graphically it is displayed as a circle here. Sorry, graphically it is displayed as a circle or as a typical class with the stereotype interface. Here you can see the notations for the interface. You can represent that interface like circle or by as a typical class with the stereotype interface. So yeah, there are two types of interface here: provided interface and a required interface. So here, provided interface, it is an interface that component provides as a service to other components. Provided means one component providing services to another component. And required interface means it is an interface that the component confirms to when requesting services from the other components. This is the required interface. Then see the relationship between components and its interfaces. Relationship between components and its interfaces. Here you can see that a representation of required interface and provided interface here. Here you can see that elided iconic form here. A provided interface is shown as a circle. Here, provided interface is shown as a circle attached to the component by a line. Here you can see provided interface is shown as a circle attached attached to the component by a line and a lollipop. That is, here you can see this. Yeah, a required interface is shown as a semicircle. Here you can see this is the required interface. Required interface shown as a semicircle attached to the component by a line and it is a socket. So here in both cases, the name of the interface is placed next to the symbol. Here you can see this is the component here and this is the dependency. See the provided interface here, circle attached to the component and the required interface shown as a semicircle attached with line to the component here. Component like user services and weather services. Okay. So this is the relationship between component and its interfaces. Then the relationship between component and its interface includes the expanded form. See the expanded form here. So here the component that realizes the interface is connected to the interface. Component that realizes the interface is connected to the interface using a full realization relationship. Here you can see the representation of realization relationship here. So here the component that accesses the services of other component that accesses the services of other component through the interface is connected to the interface using the dependency relationship. Here you can see the dependency relationship usage here. The component is dependent on another component. So here you can see the interface declaration. See the interface representation here with the stereotype interface services and having methods service selection here. Then here you can see the realization user services. Services can be user services, and here whether services is dependent on this interface here. See the usage, that is dependency here. This is the expanded, that interface is expanded from, or that uh, you can see the realization for the interface here. Then the ports. Next part of that component diagram is ports. So ports are used to control the implementation of all the operations in all of the provided interface in the component. So ports we are going to use for controlling, to control the implementation of all the operation in all the provided interface in the component. Then it is an explicit window into an encapsulated component. So here all of the interactions into and out of the component pass through the ports. It has an identity. Port has an identity. So component can communicate with the component through a specific port. Whenever we are going to communicate with, suppose one component want to communicate with another component, so we are going to use some specific port for communication between these two components. So it is shown as a small square. It is shown as a small square straddling the border of a component. So here both provided and required interfaces may be attached to that port or that port symbol. So a provided interface represents a service that can be requested through that port. And a required interface represents a service that the port needs to obtain from some other components. We have seen about provided interface and required interface. It here provided interface represent as a service that can be requested through another port, through that port for the another object, sorry, for the another component. And here required interface represents a service that port needs to obtain from some another component. Here you can see the ports here. See the component declaration is ticket seller. See the ports, number of ports here. Here, ticket sales, that is interface name. Here, port name, that is normal sale. Here you can see the port with the interface. Here, this is the port name normal sales, and that interface is ticket sales. And another here you can see the port. Port name is attractions and interface is load attractions. Then here you can see the semicircle. Another, that is require interface booking. Then require interface credit cards. This is the require interface, and here you can see the port charging. Okay, another interface is there. This is the provided interface. The circle indicates these are the provided interface, and semicircle indicates the required interface. Okay, so this is how we can give the ports to the component here with the interface. So we have seen about several notations for the component diagram. So in your exam, there may be question like, what is the use of component diagram? You have to explain that diagram with the example. You have to provide that notations for the component diagram. We have seen the notations for the port, interface, component, provided interface, and require interface. Then here, next one is the connectors of the component diagram. So here, a wire between two port is called as connector. So it represents a link or a transient link. It represents a link or a transient link or instance of an ordinary association, that is connectors. So here a transient link represents a usage relationship between two components. We have seen about that connectors in the previous diagram. The transient link represents a usage relationship between two components. Then if two components are explicitly wired together, means they are connected together either directly or through the ports. Just draw a line between them or their ports. So if two components are connected with the or that wire together, then either that are either directly or through the ports. Just we have to draw a line between them or their ports. So if two components are connected because they have compatible interface, you can use a ball and socket notations to show that there is no inherent relationship between that components. So they are connected inside this component. So there are two types of connector: direct connector and delegation connector. Direct and delegation connector. So here you can see the diagram for the connectors. Here you can see the catalog cells. These are the ports. Here you can see the components, component inventory, order handling, order taking. Here you can see the delegation connector. Here ports are connected to each other. Okay, and here you can see the number of ports are connected to each other. Yeah, this is the they are connected by ports are connected by the interface, connected by the interface, required interface and provided interface here. Now, two ports are connected to each other by interface. This is the representation of connectors. That means number of ports are connected to each other here. Here you can see the number of components and the ports for this component that are connected to each other, and the connector by interface. Here you can see ports are connected to each other by the interface. Here now we will see one example for the component diagram, that is online reservation login form. Online reservation login form. Here you can see the components. That are components means we can represent that components as a files in your system. That is, here you can see the home page is one component. Then check availability is another component. Book ticket is another component. Cancel ticket is another component. Modify form, fill form. These are the components for this railway reservation login form. See they are connected to each other. Okay, homepage contains that I will check the availability and book ticket, then cancel ticket and fill form and modify form. Okay, and that after filling the form you can cancel that ticket. Then you see the direction and the flow. You can, after filling the form, you can cancel that ticket, you can book that ticket, and you can modify that form. See the connectivity, and the arrow represents arrow moving towards that component. So this is the simple example for the component diagram of online railway reservation login form. Here see online railway reservation. Here you can see the view, reservation classes, access system. Here number of components are here. This is one package. Now all the components are included in one package here. This is the representation of package. That view package contains these components: check availability, home page, modify form, cancel tickets, book ticket, and fill form. These all components are grouped into one package. That name is view. And another package is reservation classes. That reservation classes includes these packages. These components like access database. Yeah, you can see. Then access system. Another package includes that access database component here. These all are packages, and inside that packages we are having that components. Then next part is deployment diagram. Before that, we will see about that component and class. So class and components, here you can see that similarities between class and component. So here every class and component has an identity referred by a distinct name, and distinct name for distinguishing them from the other classes or components. That means every class and every component has a unique name that are or the distinct name for distinguishing themselves. So realization of set of interfaces, dependencies, generalization and association relationship, then instances, properties and methods are there for the component and classes. So there are some differences between, there are also some differences are there between that components and classes, like that component shows the physical aspect that we have seen that example for that component contains that executable files, that is executable files like .exe files, library files, and classes shows the logical aspects, logical aspects like classes having properties, methods implemented on the data fields and messaging between the classes, and that components having a physical packaging of a logical components. In components, physical packaging of a logical components, it is at a different level of abstraction. We have seen that that component includes that classes, that is the physical packaging of that logical components, and classes do not show any such packaging, they are separate. And that components only have some methods, operations, they don't have any properties or attributes. Classes have both properties as well and the methods. So this is all about the component diagrams. Okay, we have seen about all the notations for component diagram, then we have seen the example for that component diagram and difference between components and classes and the architecture modeling basics. So that's it for today's session, we will stop here. Thank you.